So in this discussion, we continue with our discussion as we talk about, chemical formulas. So writing chemical formulas. So how do you write a chemical formula in chemistry? So this is a very important discussion. Please pay attention. So when we talk about a chemical formula, well, a chemical formula, I can simply say, chemical formula is written. So it is actually written using chemical symbols and valences. So that is what I can simply call as being chemical formula. So a chemical formula is simply written using chemical symbols and also valences, as you are going to see later on in our discussion. Now this is a very important aspect of chemistry, because if you do not know how to write chemical formulas, it simply means you'll not be able to write proper equations, and hence you'll not be able to balance them. Chemistry will become difficult, so you need to understand the language that we use. So when we are writing chemical formulas, you need to remember about the valences that I taught in my previous video, just in case you didn't go through that, of the elements and also radicals that we do have. Now when it comes to chemical formulas, there are some steps that you need to remember that can actually help you. So these are some of the steps that you need to take into consideration. Then you are going to see how I'm going to apply them as I look at some examples. So the first step when writing a chemical formula is you need to write the correct symbol of the element or radical. So that's a very important step. So you need to write the correct symbol of the element or radicals. That's why I said on the periodic table they don't give you radicals, so you need to know there's radicals. Next, you need to attach the valence of the element or radical at the top right corner. So that's what we mean. 3, you need to swap the valences of the combining elements or radicals and write them at the bottom. In this case, what I mean is that, let's say you have got the symbol X and Y, and let's say their valences is actually 2 and 3 I've attached. So you write the correct symbol of the element which I've written, then you need to attach the valences at the top right corner if you want. Then the next thing, you swap. When I say swap, it simply means you exchange. So this one comes at the bottom and that one comes at the bottom. So it simply means that if I can write it this side, it will become X. This 3 will come at the bottom of the X, and that 2 will come at the bottom of the Y. So we call them as being subscripts. So normally when they're at the bottom, we use the word they are subscripts. When normally they're at the top, we simply say superscript. So you may find such expressions in some books. So subscript, it simply means you write it at the bottom the way I've written them. Superscript, it simply means they are on top. So now once you write like that, it simply means that you have written a chemical formula. But there are a few things that you need to take into consideration. There are a few incidences that you are going to be finding, and that is why I've put up a note there. Very important for you to take note of this one, because you are going to be applying this. And as I look at those, I'll try to demonstrate right on top here to show you what exactly I mean. So it says if the valence equals to 1, if valence equal to 1, it should have been, it does not show in the formula. So if the valence is equal to 1, let's take for example in this case, after exchanging you have a 1 here and you have maybe a 2 there. Maybe after exchanging, let's say X and Y there, after exchanging you have a 1 and a 2 there. That 1 does not show, so you need to rewrite the formula, but you eliminate the 1 and just write X, Y and a 2 there, because 1 does not show. In other words, we don't show it when we are writing formula. But of course, in the back of our mind, we know that there's a 1 here which is there, so we'll put it as being imaginary. That's what the first point there says. Then the second note says for valences that distribute even, reduce the valences. So what do I mean when I say valences that distribute even? In other words, where a number can easily go into. For example, let me say if I've got element A and element B, and that is maybe a 2 and that is a 4. Remember, when we exchange the valences, it will be A, that 4 come at the bottom, and that 2 will go as a subscript to the B. But you can see that the number can be reduced. There's a number that can go there. What number? 2 can go there and 2 can go there. So you can reduce 2 there, 1, 2 there is a 2. So meaning we'll write this as A, 2. Remember, 1 does not show, so you just ignore it. So that's be the proper formula. If you want, you can reduce right on top there, and that's when you exchange. That is this also. Okay, it is going to work out. That's what we mean when valences distribute even. Suppose maybe another situation. For example, let's say you had A, and that was a 3, and you had B, which had maybe a 6. Of course, if you notice there, if you swap the valences, that would be a 6, and the B will be a 3. 3 can go there. So 3 there, 1, 3 there, 2. So I'll write it as A, 2, and that would be B. That's what we mean in this case when they distribute even. There's a number that can go there. In other words, you can reduce it to its lowest form. So you need to pay attention when it comes to that. Don't worry, this requires you to practice. Oftentimes it's not a one-day thing, but you need to practice. The last but not the least tip that I want to give you is that for valences greater than 1 and attaching to a radical, enclose the radical in brackets first, then that should be then attach the valency. What I mean is that if you have got an element, and let's say this element has a 2, then let's say that I do have a radical like phosphate. I know phosphate has got a valence of 3. So now when you exchange that, this element takes as a valence of 2. What we mean, this 2, when you exchange, will get attached to the phosphate. So you are going to write this 3 will get attached to the X, that's all right. But because this 2 is attaching to that radical, what you do is that first of all, you enclose the radical in brackets. So put the phosphate PO4, put it first of all in bracket, then that's when you are going to attach that valency. Sorry, that valence is a 2, so that is when you are going to attach the valency. So that's what we mean there. So each time a number greater than 1 is attaching to the radical, first of all put that whole radical in brackets, then that's when you attach your valency. So that's the key concept. Now let's see how we can actually get to apply these points that we have looked at by looking at these examples. So it says okay, so